project is RoboWars, which is a turn-based tank warfare type of game. One of the tanks receives its input from a user control panel, receiving a human. The other, over there, the yellow one, is completely autonomous and running off an artificial intelligence program we designed for it. The robots use several different sensors to navigate. They all have 2 light sensors here for navigating this grid here. They also have an NXTV radio to communicate with the other robots. And inside here, sorry, I can't see it, but there is line sensors and angle sensors so that they will know that they have been hit. They also have 4 motors, 2 motors to drive and 2 to operate the firing mechanism so they can attack each other. I'll now hand things over to our AI programmer, Devin.
So the entire development board is set up into a coordinate plane, starting with the square 1, 1 and continuing to the square 1 or 5, 5. And the entire AI is based around one simple algorithm, which is taking the user bot's coordinates and subtracting from the AI robot's coordinates. So the user robot goes first. That is our nice proportional line follower, which that is hoping that line follows so straightly. So Ryan just moved this and has sent its coordinates over to the AI robot. The AI robot has received them and is moving on its path to go to the shortest path to get there. So it has ended its turn now and will shortly transmit all of the coordinates back to that robot. So there's a short wait in here, and then it sends them, because we didn't want any interference from other things. We wanted to make sure that we were absolutely transmitting. So, Ryan, do you have the ready message yet? Okay. So actually, what you can't see on the control panel right now is that there are various displays on the actual control panel itself. It is displaying, say, hey, you're ready. It displays a number of shots, and it displays the current direction, the current command you just inputted to the
Now, to start off, I just want to point out that unlike a lot of teams here, our robots are incredibly adaptable because they're not limited to one form of game. It's practically infinite. If you can imagine it and code it, our robots can do it based on the idea that they all communicate. Our robots have a swarming mentality, and we've set up just one example of the multiple things we've got ready to show you exactly what they do.
Alright, so our first example, we'll start it here. The leader robot it has a color sensor, making it aware of its environment. Once it reaches the red block, it turns on infrared LEDs, and the follower robot is able to sense these infrared LEDs using its turret and go towards the lead robot. What this demonstrates is that the robots are able to share responsibility. So the lead robot has the responsibility of finding the objective. By the follower robot, all it has to do is find the leader. That way, using swarming principles, the responsibilities of the robots are distributed. I will move on.
Our next demo is going to be a simple navigation of a maze. The robot uses the turret on top to sense the distances between every single wall using its ultrasonic sensor. As it gets close to a wall, it's going to detect it and move away from it. If it's way too close to the wall, it's going to do a drastic angle change and head in a different direction. So here it's just been changing directions. Here it's going to head directly forward until it gets to the next wall. And I'm just going to wait until it's done to turn so you can understand how it's going to do that.
So in terms of materials, we actually designed and 3D printed this ourselves. So as you can see, these are the CAD designs that we worked on. So why we chose to 3D print this ourselves is basically we're taking an idea from last year where we 3D printed our project, and so why we continued this year is because of cost efficiency as well as design flexibility. So with this design, we actually have 3 tiers. On the bottom tier is house the battery as well as the motors, which are in an X configuration for the Omni wheels. On the second tier, we have the microcontroller as well as the circuitry and a servo, which is connected with a gear to the turret, which is on the 3rd tier. So on the 3rd tier, we have all the sensors which are housed there, and that is used to collect data from its surroundings.
In terms of the circuitry, the main processor is an Arduino Mega, which is also connected to an Arduino, which is essentially an Arduino Nano The Arduino Nano powers the infrared LEDs on top of the robot. The Mega powers 2 H-bridges controlling, using PWM controlling the 4 omni wheels of the robot, as well as the servo controlling the movement of the turret, as well as the infrared receiver receiving the information from the infrared LEDs.